Welcome back to Smart Interviews YouTube channel. I am 𝗥𝗲𝗃𝗃 Singh. Let's see starters 165 problems. Let's get started. So let's start with the first problem, Christmas cake. So the problem says that chef has some plans to make cakes for Christmas, and till Christmas fall, every day chef tries to make a cake, exactly one cake per day. So today is the 𝗥𝗲 day. So they are asking you how many practice cakes will chef bake starting from that 𝗥𝗲 date. So in the input you're given single value x, you need to output 7. Obviously, how can we get 7 here? So till 25th, right? So it is like 25 whatever minus the input x. So 25 minus 18 is obviously 7. If you see some other inputs, or you can also see the explanation. If you see the second input, sample input, the rate is 1. So from 1 to 25 there are 24 days. So a chef will make exactly 24 cakes. So the code looks quite easy. The logic looks quite easy. Let's start with my bad. So you'll take n value as the input and you'll just output your whatever 24 or 25 minus your n. Or better take it as x. Why? Because they're different variable x. So x. Let's just run it. Okay, let's try to submit. So cool. It was a very simple problem. Let's quickly move to the second problem. So let's start with the second problem, poster perimeter. Okay, so here you're given like chef wants to print out a poster of a rectangular piece of paper. On a rectangular piece of paper, the piece of paper uses cannot be too large, or his printer will be unable to handle it. Specifically, the length of the rectangle must be in the range of 1 to n. The width should be in the range of 1 to m. Chef would like if the perimeter of the paper is close to k as far as possible. If the chef chooses paper dimensions optimally, he wants to find out what is the minimum possible difference between the paper's perimeter and k. So basically, like, he wants to find the difference between paper's perimeter and the value k. So let's try to see the input and output will make more clear. The input format is you're given t number of test cases. Each test case has nmk as an input. In the output, you need to print minimum possible difference between paper's perimeter and k. Okay. So you're given nmk in the input. You need to output accordingly. So if you see the test cases for 5, 5 and 12, you have got 0. Why? Because you can choose like 2 and 4 whose perimeter will be 12, which is the difference is 0. So the thing is, there can be many approaches, but if you have seen the test cases here, which are like very small. So when you know the test cases are very small, you can just stimulate the things as they want, or just you can go with the brute force or naive approach. So what can be the brute force approach here? So if I say like 5, 5 and 12, 5, 5 and 12. So this is the range of length. The range of length, that means from 1 to 5 I can say, and this is the range of width. I can say from 1 to width from 5. till 5. So yeah, according to this, the brute force can be like, you can pick, let's say the range here is from 1 to 5, right? 1, 2, 3, 4 and 5. The width is here is like 1, 2, 3, 4, 5. These are the possible values you can take. But we want the optimal value such that the difference is minimum between the values picked from here, the perimeter and the value k. So here, let's say you can pick, you have 2 pointers I and j. You'll pick one from here, you'll pick one from here. You'll get the perimeter as 2 into 1 plus 1, which is 4. So for this, you'll keep a variable as answer and you can update it like minimum of the k minus whatever the perimeter is, or initialize the, you can also initialize the answer variable as, obviously you compare with the current answer, and you can initialize the answer as the maximum value in max. So according to this, now you'll update your answer accordingly 4. So k minus 4, 12 minus 4 comes out to be like 8. So this can be your first answer, initial answer. But let's say I'm shifting the value of j here. So now the perimeter come out to be like, you'll replace here with, so 3 into 2 is 6. You'll check 12 minus 6. It is 6. Which is minimum, 8 or 6? Obviously 6. So you will update your answer to 8. Before it was int max. Then it became to 8. Then when your j moved forward, it became to 6. So again, 3. Now, so 3 plus 1 is 4, 4 into 2 is 8, and 12 minus 8 is 4. So this is more optimal. So I'll update my answer to 4. Why? Because our overall target is minimize the difference between k and the perimeter. And here we are going to generate all possible perimeters. Since the limits are also very low, we can get our answer by doing the brute force itself. So let's see how the code can be. So let's take the inputs first. Before we take the input, let's declare the scanner. Let's take number of test cases. Then for each test case, we will take n, m and k. Okay, my bad. Okay, I think there is extra bracket here. Next, we need a variable answer. Answer, as we have decided, will be maximum value. Let's say integer dot max value, or you can keep it as 101 will also be fine. But yeah, let's say integer dot max value. Then we'll keep 2 pointers I going from 1 to n, a variable j going from 1 to n. Okay, 1 till n. Every time we'll generate the perimeter first, int perimeter. So perimeter formula, obviously 2 into L plus W, but here L plus W is nothing but I plus J. So I plus J. Then you will calculate the difference. So the difference you can calculate like, yeah, but when you're calculating the difference, it need not be always positive. If you check the third input, okay, if you check the fourth input test case, the input is 4. If you see the explanation for it, you can choose 1 and 1, it comes out to be 4. So the answer is 4. So the nearest answer is always, so the nearest answer cannot be always, let's say the difference can also go negative. So you should consider the mod value. So we need to handle that case also. So to handle that, I will take math dot maybe absolute, or I can take something like math dot max of 0 or k minus perimeter. I think this can also work. Perimeter. So if it goes, okay, let's say we'll take absolute. Next. And then we'll update our answer. If my answer is greater than the difference, then I will update my answer to difference. And at the end, I will just simply print my answer. Okay, what's just happened? Okay, so at the end, I can just print my answer. So 0133, let's submit our code. Yeah. So this was also kind of simple problem. Just you need to go with the brute force approach. Since the limits are also quite less, it can work. Let's jump to the third problem. Okay, so in this problem, you're given like a shop has n items for a sale. The ith item has a cost of ai, obviously. So you would like to purchase all the n items. Fine. The shop offers a discount whenever an item is bought. Okay. All the future purchases have their cost reduced by 1. Okay. However, the cost of an item also cannot fall under 0, so it can't be negative. So you can buy items in any order. Okay. So it's like a greedy kind of problem. What's the minimum possible cost of purchasing all n items? In the input, you're given like t followed by a variable n and n followed by n integers, which are nothing but the array elements. For each test case, you need to print minimum possible cost to buy all the n items. Okay, the constraints also look like quite high. So this need to be like a n or n log n kind of problem. So if you see the test cases here, so the test cases are like 4, 3, 2, 2. Okay, we'll go with the last test case, 3, 1, 4, 1. So 3, 1, 4, 1, the output is 3. Okay, so let's just see this. So 3, 1, 4, 1. You are having like 3, 1, 4, 1 for this. If I go with the logic, what they have said. So let's say I bought this for 3 rupees. Then all this I will get a discount of 1. So that means for this 1, 1, 1. That means if I get a discount of 1 rupee, this is nothing but I am purchasing for 0 rupees. Okay, if I purchase this for 0 rupees, this discount goes to 2. Now, when I come here, the discount is of 2. So the answer will be like 4 minus 2, that means 2. The discount goes to 3. But this is of cost only 1. So obviously it's of cost 0. This is coming to be 5. That means we should not pick in the straight order. We should go for like something optimal. Let's see, if you are trying to pick optimal, you should go with the lower ones first, the lowest cost, 1, 1, then 3, then 4. That means there is a need for sorting. Let's sort the data and then see what can we do. So the sorted data is 1, 1, 3, 4. When I'm here, if I buy it for like, if I buy it, its cost is 1. That means discount is 1. If you see, the discount is like increasing. At this, the discount is 1. At 3, the discount is 2. At 4, the discount will be 3. At initial item, the discount is 0. So I hope you are understanding. When I come here, the discount is of 1. So 1 minus 1 is 0. Then when I come here, the discount is of 2. 3 minus 2 is 1. When I come here, the discount is of 3. So 4 minus 3 is 1. In this way, we can get the output as 3. So it's quite easy. First, you need to sort the array. Once you sort it, step 1, you need to go in this order. But there's also a catch. You need to also handle like, in this case, let's say if you're having some lower value here, if you're having like all ones, when you're calculating the answer values for this, the discount is for 3. The discount here is 2, but the price is 1. So you can't do simply like the array of I minus the index. You need to also compare it with the maximum. You need to also compare it with 0. Whichever is maximum, you need to add it to the answer. Simple. So first sort it. Second step, go one by one by doing this operation, and whatever the discounted value is, compare it with 0. If it is going negative, you should take it 0 and simply add it to the answer. Cool. Let's try to implement it. So we need to let's just take the input first. After taking number of test cases, for each test case, I need to take n value. By seeing the test case, I think there is no need to go with fast IO. It can simply work with scanner. So after taking the array values as the input, we'll start the logic. We need a variable answer having a count of 0. Then, before we start the logic, we need to sort the array. We can simply use inbuilt sorting. Once we have sorted, we'll start from 0. And we need a discounted value, int discount. So you can go with discount, or else we can simply use the indicator here, I. So answer plus the maximum of 0 comma the discounted value, which is array of I minus I, and then simply print your answer. So yeah, let's try to run it. Okay, yeah, I think do we have any other errors? No. Okay. Yeah, so this was completely a greedy problem. So let's jump to the next problem. Let's jump to the fourth problem, stable arrays. Okay, so let's start with this problem. So you're given an array A of length n, and every second the following process will happen. So let me just zoom in a bit. Every second, the process is like, if your A of I is less than A of I plus 1, you need to set A of I to A of I plus 1. For example, if you have 31415, at a second, what will happen is, if, okay, there is some explanation, you will see that A is said to be stable if none of its elements change the process. How many seconds will it take A to become stable? So they are asking you nothing but the time to become A stable, and A is stable when no elements change, when this process is happening again and again. And obviously, by seeing the constraints, we know that we can't stimulate it. Why? Because the constraints are high. So let's take the example of 3145 and understand. So for 3145, the output is 4. 31415, the output should be 4. So how are we getting? So at t equal to 1 time, we need to start the process. Is is 3 less than 1? No. So 3 will be here, 1 will be here. But is 1 less than 4? Yes. 4 will be here, 4 will be here. But yeah, before you keep the value here, check. Is 4 less than 1? No. Is 1 less than 5? Yes. So 5 will come here. At t equal to 2, it is like 3 will be here. Okay, you need to compare. Is 3 less than 4? Yes. 4 will come here. Is 4 less than 4? No. Is 4 less than 5? Yes. Is 5 less than 5? No. No. T equal to 3. Then repeat the process. Is 4 less than 4? No. 4 less than 5? Yes. And this all will be same. T equal to 4. 4 less than 5? Yes. 5 less, yeah. Again, it will be same. And if 5 less than 5? No. Everything will be same. So do you see, at this time, if you repeat the process from here, the array will be same. It won't change. So you need to output this time. I hope you have understood the problem. To understand it better, let's take a different example. What if we have an example like, let's say 3, 4, 10. So here, I am not going to repeat the process at a time. I am not going to repeat the process at t equal to 1, t equal to 2. Let's just try to understand. First thing, will the last element change at any time? No. The last element will always be same. The last element will try to change this one. Can 7 update 6? Yes. So 7 can update 6. Now, can 7 update 9? No. So the updation of 7 will stop here itself. At max, this will be 7. Only one element, it can change. Now let's check with 9. Can 9 update 5? Yes. Why? Because 5 is less than 9. Is 9 less than 2? Yes. 9 less than 1? Yes. But is 9 less than 10? No. Is 9, my bad. I think I have told wrong. Is 5 less than 9? Yes. So it can convert it to 9. Is 9, is 2 less than 9? Yes. Is 1 less than 9? Yes. Is 10 less than 9? No. So 9 can't update 10. Okay. But 10 can again update these two values. Why? Because they are less than 10. So it is something like you need to find the another maximum. So it's this problem is the variation of one of the famous problem, finding the next greater element. So this is a problem of monotonic stack. So this is one of the famous problem. If you are aware of this problem would be like a very easy one. So so let's see what is this monotonic stack. But yeah, let's see how we can use the logic in this. For the current problem, since we are only keeping track of time, and we can keep off time with the help of indices. We can directly keep track of time with the help of the difference between indices. Or else you can use a variable current to max, something like that. But yeah, if you're trying to store the answers, then you might require stack. For the current problem, let's see how we can do without stack. So yeah, let me just take this array itself. 3, 4, 10. 2, 5, 9, 6, 7. So let's see. For this, I will take 3 variables. Okay, I guess it is a bit up and down. 5, 9, 6, 7. For this, we should get the output of obviously 3. This is 2, this is 1. Out of 1, 2, and 3, the output should be 3. So, in this problem, I will take a variable answer, initially 0, your current time is also 0, and current max. Current max, since I am starting from, let's say, from the end, my current max initially will be 7. Array of, you can say, n minus 1. So I will start my iterations from I minus 1, n minus 1, n minus 2. Let's start the logic. Is 6 less than 7? Yes. So update my current time. Okay, 6 less than 7, fine. Is 9 less than 7? No. So update your, first of all, update your answer to, so which one is maximum? 1 or current time? Current time is maximum, update it to 1, and make your current time to 0. And current max will update to 9. Decrement I. Is 5 less than 9? Yes. Is 2 less than 9? Yes. Is 1 less than 9? Yes. But is 10 less than 9? No. So update 1 and 3. The maximum is 3. Update your answer with 3 and reinitialize your current time to 0. And max is 10. I is 4 less than 10? Yes. Is 3 less than 10? Yes. So here we don't have any further elements. So after the loop, you can simply compare with whichever is maximum. Obviously, since answer is maximum, I'll not update my answer. And yeah, directly return this to the calling function. So this is how it can do without using any stack. Let's try to see the code. Yeah. Give me a minute. So after taking number of test cases, for each test case, I will take n. I will take array elements. Here, let's start our logic. I need a answer variable. I need a current max, which is n minus 1. I need current time. So let's start our logic. Oh, my bad. We are starting from backside, right? So n minus 2 till I greater than or equal to 0, I minus minus. Every time, update your answer like, okay, every time check if your current max, if it is greater than your array of I, simply current time plus plus, I can do it. Else, first of all, update my answer to maximum of my answer and current time, and initialize my current time to 0 and update my current max to a of n minus 1, a of I. And at the end, just cross check with your answer. Answer is, just repeat the same 27th line here. Compare with your current answer and current time, and then you can directly print your answer. Let's see. Okay, I guess, yeah, we have missed something here. Yeah. Any other errors? No. Let's see how our code works. Oh, the same thing. Yeah. I should better stop using this underscores, but I should go with something else. Yeah, we are getting the answer as 0224. Yeah, let's see. So yeah, it was a interesting problem. Interesting problem on, yeah, a simple array. Thank you so much for watching this video till the end. I hope you have liked it. If you have liked it, like, comment, share and subscribe, and mention in the comment box what content would you like us to create. And yeah, meet in the next video. Bye.